Welcome to Goldfish on Games, and today I'm extremely pleased to announce the release of MegaAtoms for the MegaDive, or the Genesis if you prefer. This is the 0.1 release, which means that it's actually fully playable, but there's still a few rough edges. And these are left in on purpose because I plan to do these videos for each big release. And so you can give me feedback, and I can show you how I went around making the game. So this first video is going to be how I got the 0.1 release done. And so let's take a look at the current state of it. Amazingly, it's actually looking really good. Half of that is because I was able to take graphics from previous versions and import them, and then clean them up, tidy them up, and do a lot of extra processing on them, because the MegaDive is quite a different beast to the ZX Spectrum, to the DS, to the Xbox 360 that I worked with previously. And so let's take a look at what we actually have to work with, because as we know, hardware is king. So what did Sega give us inside the MegaDive? Start off with, we have a 7.6 MHz Motorola 68000 processor. This was paired with a 3.5 MHz Z80 CPU, whose primary job was to organise the audio, but was also used for backwards compatibility with the Master System. The graphics was provided by the VDP graphics processor. We will look at that in more detail in a second. That was paired with 64 KB of RAM and 64 KB of VRAM. Finally, there was two sound processors, which is why we needed the Z80 to coordinate them. The VDP allowed us to draw two background layers, A and B, with very limited alpha between the two. On top of that, we could also draw up to 80 sprites on the sprite layer. The backgrounds were drawn using 8x8 pixel tiles, which all had to be in the VRAM. Sprites were allowed to be up to 24 by 24 pixels in size, which also had to fit inside the VRAM. Everything had to be drawn using one of the 4 palettes. Each palette could have 16 colours, but as normally one of the colours would be transparent, you only really had 15 colours to work with, and typically you would have repeated colours between different palettes, such as black or white. All these colours could only be picked from a system palette of 256 colours. The audio is provided by 2 chips, the FM synth, which provided 6 channels, and the PSG, which provided 4 channels. PSG also allowed us to do samples. Now, as you can imagine, this was massively more powerful and more flexible than the ZX Spectrum. But I really wanted to make a game that looked, sounded and played like a 16-bit title, so I was going to have to really put in a lot more work than I did for the ZX Spectrum version. Now thankfully I found a development environment called SGDK, which allowed me to write the whole game in C, which is the same I used for the ZX Spectrum version. This meant I could do a lot of the same things, like use Visual Studio, test in an emulator, get that rapid iteration cycle going again. This significantly sped up my development time for the game, and made it quite fun. Now, I decided I was going to do a lot of things differently to the other versions, including pulling everything out of a single file, because I really did not like that idea at all. And to make it easier on myself, I wrote a basic state machine. Now, you can think of these as just a way of trying to organize code and trying to give yourself some small functions so you can do things every time you start a state and end a state. So let's take a look at some examples of what I use this for. So this release of the game is split into a title state, a player select state, a game state, and then a winner state. And when I transition from one state to the other, I try to clear down any graphics that I've loaded, and then load in the graphics I need for the next part. And this makes it quite neat and tidy, as I know that if I go into a state, I will have all the graphics I need, and when I leave a state, I will try to make sure I've cleaned everything up, so whatever comes next will have a nice fresh environment to work with. This is really good practice, and I'm happy that I was able to create something in C that allowed me to work in this fashion, and I was really quite happy with the code. Now if you're interested in the code for this or any other part of Atoms, I put it all up on GitHub, because I was wanting to give back to the community, so you can have a look at how I work this. Now, I'm not working directly in GitHub, so you'll only see code updates whenever I put up a major release, but you'll be able to still see the differences I made between each version. If you look at the code, you might recognise some bits from the ZX Spectrum version. That's right, I was able to take some of the code from the Spectrum and bring it over, in what is probably a world first for this type of thing. But with the code going quite nicely, it's time to start looking at the graphics and how I went about working with them. Because we are limited to those 4 palettes with 16 colours, I had to be very creative how I drew everything on screen. So let's take a look at the main game screen and see how I broke this all down. Here I've loaded up the ROM inside the Exodus MegaDive emulator. Now, this is an interesting emulator because it's quite low level and gives you quite a lot of easy to use tools to access the various hardware. So you can actually see what's in the VRAM, you can look at what the planes are doing, you can even enable and disable various layers. This makes it really good for debugging, as well as looking at how various games were made. So in ours, let's take a look at what I've got on the backmost layer, layer B. And unsurprisingly, it's the background. This is using palette 1, and it uses a very small amount of VRAM. If you look at the VRAM, you can see from around about here down to here, that is all the tiles we need to display that background. And this is actually quite a small number and gives us lots of space for more tiles. This was mostly achieved by making sure that all the grids actually aligned with the 8x8 grid used by the MegaDive. Now if we enable the next layer, you might be surprised to see that it's actually the atoms. Yes, I decided to draw the atoms to the screen using one of the background layers. The main reason for this was that if I drew them with sprites, I'd be using almost 70 of the 80 sprites that we can actually use, which would be pretty much wiping out all the sprites that I could have. Putting them on a background layer meant that I could very quickly update them as well as being able to control exactly where they all were without using any sprites at all. Now there might be a better way of doing this, but this seems quite straightforward to me. These are also being drawn by palette 1, so I'm already using 2 of the 4 palettes. The reason for using an entire palette just for the atoms is that I am duplicating the atoms across the entire colour set, as we can see in this image. I can't really dedicate a palette per atom as I've done on other platforms, so I needed to use one palette to draw them all. And the only way I could think of to be able to do that was to be able to put them all on a single tile set. This does make it surprisingly easy to be able to work with when I draw to the screen, because it's just a few simple lines of math, gets me to any point in the tile set. If we look at the VRAM viewer and select palette 2, we can see the atoms occupy this space here. Now what you might be able to notice is from here all the way down to here is garbage from previous screens. These are not used in this, which means I've got all that space to work with if I wanted to put in more graphics. So if I enable the window, we see nothing new. I don't use the window at all, it's not really much use for a game like this. So when I enable the sprites, what we're going to see? Well, we have a cursor, and we have the who's playing and who's coming up next. The cursor is being drawn using the same palette as the atoms. And this makes sense when you think I'm doing almost exactly the same thing with it. As you can see, I'm using one big page with all the various colours on it. For the professor icons, these are currently using palette 3, and if I had a robot on screen, they'd be using palette 4. This seemed to make sense to me, as it meant that I had more colours to really make these icons look really expressive, seeing they're quite big on screen, and it meant that they were able to look really nice. We can actually see them in the VRAM viewer as well. You can see palette 3 is here. Select palette 2, we can see the animated cursor doing its thing down here. Now one of the other things I'm doing, if we look at the plane view, we can see that I've actually offset layer A. So if I put that layer back to 0, 0, it would be drawing the atom up here. But by just moving the background plane, it ends up in the right place, and then everything else lines up nicely from there. This meant the maths itself was relatively simple, and it meant I could easily move things around with the backgrounds and everything without having to worry too much about having to modify bits in code too much. And finally we come on to audio, which historically has been a bit of a problem for me, and I thought the best way to try and get around this was to use sound effects from previous versions that actually worked quite well, and these imported really nicely. For the music, however, I had to take some MIDIs from an old Games Factory CD and then import them through a few tools, which gave me this VGM file, which is what you hear in the game. It's not perfect, but it's something we can work on for the next release, which neatly brings us on to where do we go next. Now, obviously improving the audio, but also trying to improve the graphics and add in some animation, because other versions have had some really good animations, and I can think of many ways of trying to bring these in. As well as this, I want to work on a new game mode. This would use the rule set of Atoms, but in a very new way, mostly in a single player style puzzle experience. Whether or not it's a set of levels where you have to complete, or it's some sort of continuous play, I'm not sure yet. If you've got any ideas, let me know. I've got a few myself, and you might start seeing some prototypes or something like that in future versions. And so if you do want to feed back to me, either leave me comments here, contact me on the GitHub or anywhere else you can find me, including Twitter. Now, if you want to find out when next videos are coming out, subscribe is probably the best way of doing it, I'm afraid, as I have no timetable yet for when next releases are going to be. It's just when I get round to them. And so, until next time, I've been the Goldfish, and this has been Goldfish on Games.